I'm going to talk about the state of Lenovo notebooks running coreboot. I'm Patrick. I've got a Bachelor of Science in Electrical Engineering, and I'm a coreboot developer since 2015 with the focus on Lenovo devices. This talk is privately motivated. I'm not affiliated with companies mentioned here, and I'm not sponsored by those. Yeah, my interest is in coreboot and open source software. Got me the job at 9-Element Cybersecurity, where I'm currently working as hardware and software engineer. All information gathered here are from free and open source software projects and might not be accurate at all. So why are Lenovo so awesome? There are a few points. They have a big community backed on them. There's a wide variety of platforms, like they support the Intel Core 2 Duo, Intel Nehalem, Intel Haswell, and have first-class support. Are still actively maintained, which is kind of cool because they're so old. There are no proprietary blobs to operate them. So it's 100% free software if you don't count the microcode and Intel ME. They're very, very cheap on the internet, like on eBay, and easy to buy, and have a racked case, which is important for me. And they have good documentation, and you can even find schematics online. I'm going to talk about the past, give some statistics, show the current state, that's work in progress, and have a look in the future. So what happened over the last few years? I just walked through the coreboot source and collected some information. Starting with 2015, all boards got TPM 1.2 support. We fixed some issues with the shutdown and ACPI code. On the T400 and T500, we got the hybrid graphics support. We fixed some issues with the audio codec. And on the X200, we got pen support for the tablet mode and fixed some panel flickering. The X60 and T60 got blob-free graphics in it, so you don't need the VGA option ROM anymore. And on the newer platforms like Sandy and Ivy Bridge, we got the free RAM in it, USB 3 support, PC Express graphics in it, and IOMMU support. So before that, they used the MRC blob provided by Google, and yeah, in 2015 it was replaced by open source software. In 2016, we got support for improved support for the embedded controller and fixed some issues with the keyboard. We started to use shared source code for the GPIO driver, shared hybrid graphics driver, and got initial support for dual graphics. Up to this point, it was only possible to use the integrated Intel graphics. The device is shipped with an yellow USB port that can be used to charge a phone, which is essentially always on, even if the device is powered off. And we got support for libgfx in it, which is graphics in it written in Ada Spark. We fixed lots of problems with the docking code. On the older platforms, you need software to enable the docking station. We, on the X200, we added CPU-C states. On the newer platforms, support for eSATA, native RAM init fixes, and yeah, lots of other fixes to make the native RAM init more stable. So there are lots of corner cases that's properly handled by the MRC bin blob, but They weren't handled by the native code. We added support for the postcast stage and libgfx init. In 2017, there were lots of changes across all boards, like support for the Bluetooth dongle. It can now be toggled from the OS. Support for additional USB always-on mode. LED control using the Linux ThinkPad ACPI color model and fixed CMOS layout. We have support for the sync light. We now share the hybrid graphics driver on all supported models. Again, we rewrote docking code because it still was broken and added some support for buttons and LEDs, which is kind of useful on docking station. And imported the USB always-on support to more models. In 2018, there have been basically some code cleanup. Because developers tend to just copy-paste an existing mainboard port and just leave everything in that's might not be needed, so we try to get rid of that. We added support for the Intel VBT binary to enhance the graphics in it. We dropped the C native graphics in it because it does not handle all corner cases, while the new libgfx init is able to support every connector, every mode, and has a way better hardware support. On the T400 side, there had been a unified code base, so we dropped all the different mainboard models and put it into one unified code base because they all use the same mainboard reference design. On the newer platforms, we now have dual graphics features enabled by default. We can power down the discrete GPU when only using the Intel GPU, which is kind of cool because it saves about 5 watts of idle power. And we have support for the VWAN card detection. And this year, there's again some cleanups around ACPI, removed headers, improved SM BIOS table, and yeah, we support more entries in the SM BIOS table. We were finally able to set the battery threshold limit using ACPI. Removed some unused C states and hardware in it, added more VBTs, and fixed some issues with the dual graphics. And yeah, that's... Oh, okay. And there's the parallel MP in it that saves us 26 milliseconds boot time. So as you can see, it takes years to fix bugs and get this boards on a state where it's compatible to the vendor firmware, just because everything is driven by the community. So some statistics. As you can see, there were lots of boards added in the last few years. And right now we have 31 supported Lenovo boards. Some more statistics. These are gathered from the source mainboard Lenovo folder. As you can see the middle spike here is in 2014, there were over 200 commits, which seems to be kind of cool. But if you look at the next slide, we can see that in 2014, lots of files were added and removed again. And then again, lots of files were added and removed again. So there were a very high code fluctuation. Yeah, and as you can see over the time, we are adding and adding more boards, so it's growing very slowly. Yeah, as you can see, we're doing some code cleanup, so all the spikes are files that are being added and removed again. Some more statistics from the mainboard folder. 1/3 of the code is written, or that's present there is written in C. We have 1/4 is ACPI code, and the remaining files are just something that glues everything together, like device tree, header files, kconfig and make files and stuff like that. So work in progress. We have the verified boot, original developed by Google on the Chromebooks. It only works on the Sandy Bridge. The trick here is to use the function key. If you hold it down at the boot, you can go into recovery mode without opening the case. And work in progress, we're working on protecting the SPI flash using the Intel's protected region inside the SPI controller. And we're porting the verified boot to other platforms. You can see here the Garrett change if you're interested in it. To do, port the reboot code to other platforms and enhance the reboot support in the payload. There's NVIDIA Optimus. Basically, it's an ACPI feature, but there's no specification available. Lenovo uses the system management mode, so it's difficult to understand what's going on in the firmware level. And I was using the Novo as reference and got a basic implementation on the Lenovo T520. It's kind of working, but need tests on other platforms and on regular use cases. And we need to port it to other platforms. That's not done yet. There's more interest in code deduplication, trying to move everything to the device tree. Right now, everything is hard-coded in C, which kind of makes no sense. We try to share more code between boards that are very similar, and yeah, so some stuff already has been done this year. There's more to do, like the MRC configuration could be entirely put into device tree. And yeah, there's way more stuff like GPO configuration, audio codec configuration could be moved to device tree, and yeah, we could even merge boards into a variant scheme. There's the Lenovo T440p support. It's in Garrett right now. Basically, everything's working. Besides the embedded controller space, it has some new bits that are unknown, undocumented. And yeah, what needs to be done? We need to find out how it's working. Dual graphics. We need to port the NVIDIA Optimus and improve the ACPI support on that. A small comparison between current coreboot and the vendor firmware. So we have no blobs in coreboot. Support end-of-life firmware on all devices. NVIDIA Optimus on coreboot side is very experimental. Reboot is working, but we don't have secure boot, while the vendor firmware has. And we don't support embedded controller firmware updates because it's completely undocumented. But there was a cool talk on the Black Hat this year, so we might support that too in the future. Possible future work. We got the T480. It has a boot guard, but if you got it, sorry, does it play? Oh yeah. So all those devices have Intel boot guard. If you got one that does not, you can change the firmware and run coreboot on it. The Thunderbolt support is still missing, but System76 ported it to their laptop series. So once they upstream it, we have support for that too, and then basically everything should work. As you can see here, you just have to replace the firmware chip with coreboot running Tiano Core's payload, and then it boots up and shows these coreboot logo here instead of the vendor firmware. Next slide. Here we go. We could add support for the Thinkpad E495, and it's a Ryzen 3. Google added support for the Picasso SoC for their Chromebooks, so it should be easy to support. Has a 16 meg flash. Maybe someone is interested in supporting that too. then we have some ideas to reduce the ACPI code, get rid of legacy stuff nobody uses anymore with modern ACPI-aware OS, because it's easier to maintain and probably have faster boot times. There's interest in supporting the firmware update daemon, provide free coreboot builds. That's only possible for coreboot and blobs that have compatible license. And we want to use vboot on all those boards just to have a secure platform that has a recovery mechanism in case something goes wrong. And there's some more, we need to improve the Windows 10 support or Windows support in general. It needs special ACPI code. The Thinkpad daemon running on that needs special ACPI functions. And NVIDIA Optimus, I'm not even sure if it's possible at all. But our community main interest is in Linux, so we need to evaluate if that Windows 10 can be improved. And that's it from my side. Do you have any questions?
Right. Please queue up at the mics again.
For the T480, I'm just a little bit confused. You said you need a model without BootGuard enabled, but
Yes.
they all come with BootGuard? Is it just...
They all ship with BootGuard, that's true.
But it's not enabled on some models?
It is enabled by all models by default.
Okay, so then how can you install coreboot then with BootGuard?
You can't. With BootGuard enabled, you can't. So the device you saw in my presentation is a special device. That's not, how do you say? You can't buy it in the retail market. So it's a special device.
So you need a special add-on or something.
Yeah.
Okay.
Test. Do you know if the AMD notebook has something like BootGuard?
I don't know.
Okay.
So we just have to evaluate it.
All right, then that's it, I guess. Thank you very much.
Thank you.